Have you ever looked up at the clouds gently drifting across the sky and wondered about the winds that push them? Now, imagine those winds, but amplified to a scale so immense, so powerful. It's almost beyond our earthly comprehension. That's what we see when we look at the beautiful swirling bands of Jupiter. The difference between the winds on Earth and the winds on Jupiter is not just a matter of degree. It's a fundamental distinction that reveals the sheer power and scale of our solar system's largest planet. On our home planet Earth, the winds that drive our weather systems are themselves impressive forces of nature. A gentle breeze might be just a few miles per hour, barely rustling the leaves on a tree. But we also experience much more powerful winds. A strong gale can reach speeds of 40 to 50 miles per hour, making it difficult to even walk. And then there are the hurricanes, the most powerful storms on Earth. The strongest hurricanes, classified as Category 5, have sustained wind speeds of over 157 miles per hour, or about 252 kilometers per hour. These are incredibly destructive forces, capable of causing widespread devastation. These winds on Earth are primarily driven by the sun's energy. Solar radiation heats the planet unevenly, with the equator receiving more direct sunlight than the poles. This temperature difference creates pressure gradients in the atmosphere. Air flows from high-pressure areas to low-pressure areas, and this movement of air is what we experience as wind. The Earth's rotation, through the Coriolis effect, then deflects these winds, creating the large-scale circulation patterns and swirling storms we see on weather maps. Topography, like mountains and oceans, also plays a huge role in shaping local and regional wind patterns. Now let's journey over 365 million miles away to the gas giant Jupiter. Looking at Jupiter through a telescope, the first thing you notice are its distinct, colorful stripes. These are not solid surfaces, but massive bands of clouds, primarily made of ammonia ice, stretching all the way around the planet. These bands are known as zones, the lighter-colored bands, and belts, the darker ones. The real story here is not the clouds themselves, but the winds that separate them. These are not winds in the earthly sense. They are colossal jet streams, rivers of gas, flowing at mind-boggling speeds. Scientific measurements, gathered by spacecraft like Voyager, Galileo, and more recently, the Juno mission, have given us a clear picture of this extreme weather. On Jupiter, the winds within these jet streams can easily reach speeds of 335 miles per hour, or about 539 kilometers per hour. That's more than double the speed of the most powerful hurricane ever recorded on Earth. Imagine a continuous, planet-wide storm where the winds are always blowing at twice the force of a Category 5 hurricane. It's a level of atmospheric energy that is difficult for us to truly grasp. But why are Jupiter's winds so incredibly fast? The answer lies deep within the planet's structure and its fundamental properties. Unlike Earth, where the sun is the primary engine for weather, Jupiter generates a significant amount of its own internal heat. This heat is a leftover from its formation, billions of years ago, and is still slowly radiating out from its core. This internal heat source is much more powerful than the solar energy Jupiter receives, given its vast distance from the sun. This heat, rising from the deep interior, creates powerful convection currents, like water boiling in a pot, but on a planetary scale. These massive, churning movements of gas are the primary driver of Jupiter's extreme winds. The planet's rapid rotation then organizes this chaotic movement into the organized east-west jet streams we see as the famous stripes. Jupiter spins on its axis incredibly fast, completing a full rotation in just under 10 hours. This is more than twice as fast as Earth. This rapid spin creates a very strong Coriolis effect, which stretches and shears the rising and falling gas into the distinct, parallel jet streams that circle the entire globe. There are a great number of these jets, far more than on Earth, creating the planet's striped appearance. A fascinating piece of scientific research has delved even deeper into this mystery, quite literally. Data from NASA's Juno spacecraft has allowed scientists to probe beneath Jupiter's cloud tops. Juno's gravity measurements have shown something remarkable. These powerful jet streams are not just a surface-level phenomenon. They extend deep into the planet's atmosphere. The research indicates that these weather patterns, the zones and belts driven by the jet streams, penetrate to a depth of about 1,900 miles, or 3,000 kilometers. This is an astonishing depth. To put that into perspective, if you could stack the entire continent of Australia on top of itself more than 3 times, that would still be less than the depth of Jupiter's winds. This discovery tells us that Jupiter's weather is not just skin deep. It's a deeply rooted, massive system that involves a huge portion of the planet's outer layers. The sheer mass of gas involved in these flows is immense, which helps to explain their incredible speed and stability over time. While Earth's hurricanes might last for a week or two, Jupiter's features, like the Great Red Spot, a storm larger than our entire planet, have been raging for centuries. So when we compare the winds of Earth and Jupiter, we are comparing 2 fundamentally different systems. Earth's winds are a thin atmospheric layer, driven by external solar power and shaped by a solid, varied surface below. Jupiter's winds are a deep 3-dimensional system, driven by the planet's own powerful internal engine and organized by its incredibly fast rotation. The number of jet streams on Jupiter is much higher, and their speeds are in a league of their own. Looking at Jupiter's majestic, striped face is a reminder of the incredible diversity and power found within our own solar system. It shows us that the gentle breezes we feel on Earth are just one expression of atmospheric dynamics in a cosmos filled with extremes. The laws of physics are the same, but the scales are unimaginably different. We hope you enjoyed this journey into the stormy atmosphere of our solar system's giant. To learn more about the wonders of our universe, make sure to subscribe and follow Space Repo.